Questions 21 through 25 on the 2014 Grade 12 AMC 12B. In the figure, ABCD is a square of side length 1. Rectangles JKHG and EBCF are congruent. What is BE? Let's label a few things here. BE I'll call C, KE I'll call A, and EJ I will call B, like that. And in a very similar way, this is also going to be B up here, and this is going to be A. It's wrong to assume that this is the same as that. It's tempting to think that, but it's actually not the case. And then, of course, this is going to be 1. This is 1. This is 1. From here to here is 1 minus C minus B. And from here to here is 1 minus A. And then another thing you'll notice, if you label some of these angles, if I call this angle, let's say X, and this is of course 90 degrees, this will be 90 minus X, that angle. Those same angles exist in this little tiny triangle right there. So that basically means that the first thing is we have some similar triangles, and that's KAJ is similar to JAG. And then from Pythagoras, since this is also C, since those two triangles are congruent, we have A squared plus B squared is equal to C squared. So now let's look at the similar triangles relationship. From that, we will get that A over 1 minus C minus B is equivalent to B over 1 minus A is equivalent to C over 1. Now, from these, we can get the following relationships. If we use these two, we can get B is equal to C times 1 minus A, which would be C minus CA, like that. And therefore, AC is C minus B, like that. And then from this guy, this Pythagorean relationship, we can get that A squared is equal to C squared minus B squared. And that factors into C minus B times C plus B, like that. So now, as you can see, you can substitute one into the other. You can substitute this into here. And when you do, you get A squared is equal to AC times C plus B, like that. So far so good. No tricks. Now we look at this and this, those two, equate those two, and when you do, you get A is equal to C times 1 minus C minus B, like that. And that will allow you to substitute again. From here, of course, if you cancel out an A on either side, you get A is equal to C times C plus B. So I can put that over here. Instead of A, I can just put C times C plus B, like that, is equal to C times 1 minus C minus B. Well, the C's cancel from both sides, so you get C plus B is equal to 1 minus C minus B. And from this, you get 2C plus 2B is equal to 1, and therefore C plus B is equal to a half. And from that, we can write that B is equal to 1/2 minus C. All right. And if we substitute this into this guy, we get that A is equal to C times a half, like that. So we have A in terms of C, we have B in terms of C. We can now plug them all into there and solve for C, which is exactly what they want us to solve for. So let's do that. So A squared plus B squared is equal to C squared. A squared is going to be C squared over 4, this right here. B squared is going to be 1/2 minus C all squared, and this is C squared. When you simplify this whole thing, you expand it all out and collect like terms, you get c squared minus 4c plus 1 is equal to 0. And then use a quadratic on this, and when you do, you get c is equal to 2 plus or minus root 3. And of those, the answer choice listed is this one, C, for number 21. In a small pond, there are 11 lily pads in a row, labeled 0 through 10. A frog is sitting on pad 1. When the frog is on pad n, where n is greater than 0 but less than 10, it will jump to pad n minus 1 with probability n over 10 and to pad n plus 1 with probability 1 over n over 10. Each jump is independent of the previous jumps. If the frog reaches pad 0, it will be eaten by a patiently waiting snake. If the frog reaches pad 10, it will exit the pond, never to return. What is the probability that the frog will escape being eaten by the snake? So we have pad 0, 1, 2, all the way up until pad 10. Now, a really helpful thing to realize in this question is that the frog starts here, right, at pad number 1. But if the frog reaches pad 5, then because of the symmetry of this diagram, it has half the probability, 50% of going all the way here, and 50% probability of going there. So that's very important. So by symmetry, if the frog reaches pad 5, the probability is of half of going to pad 10, and the probability is 1/2 of going to pad 0, where the snake is. So we are interested in him obviously going away and escaping. So before we jump right in, let's create just a few examples of what can happen. So he starts here, and based entirely on the question, the stem, and the information, if he is going to go here, that happens with a probability of 9 over 10. And if he goes here, it happens with a probability of 1 over 10. That's entirely based on the question. If we keep going, and we are now here, pad 2, the probability of going back to pad 1 would be 2 over 10, and the probability of going to pad 3 would be 8 over 10. If we are at pad 3, the probability of going to pad 2 would be 3 over 10, and the probability of going to pad 4 is 7 over 10. And then similarly, if you're at pad 4, the probability of going to pad 3 would be 4 over 10, and the probability of going to pad 5 would be 6 over 10. All right, so now we have to combine all of these. So if you're at pad 1, and let's give a definition first. Let pk represent the probability that the frog escapes if it is on pad k. So, based on that definition, P1 is the equivalent of 9 over 10 P2, right? Because he was here, and in order for him to go there, the probability is 9 over 10. And very similarly, P2 is going to be calculated as follows. First, we have to figure out 2 over 10 P1, right? 2 over 10 P1 plus 8 over 10 P3. There we go. And then P3 is going to be 3 over 10 P2, right? 3 over 10 P2 plus 7 over 10 P4. And then P4, that is going to be 4 over 10 P3, right? 4 over 10 P3 plus 6 over 10 P5. And then finally P5 Well, we get that one for free since we had established that the probability of escaping when you reach pad number 5 is a half. Because of the symmetry of the diagram, it's a half to go there and a half to go there to 0. So P5 is actually a half. So now what we have here basically is a system of equations. We have 4 variables, P1, P2, P3, P4, and we have 4 equations. We actually have 5, but the 5th one just gives me a direct value for P5. So you solve these system of equations, and you guys know how to do that. And when you do, solving this, you get P1 equal to 63 over 146. So that basically means that because he starts off on pad number 1, 63 over 146 is the probability that the frog will escape. And therefore, number 25, the answer is C. The number 2017 is prime. Let S be the sum from k equals 0 to 62 of 2014. Choose k. What is the remainder when S is divided by 2017? 2014 is the same as negative 3 mod 2017, right? The remainder when you divide by 2017. So if we were to take this 2014 choose k and expand it all out, we would get the following: 2014 times 2013 times 2012, and so on, all the way down till you get to 2014 minus k plus 1. And that's going to be all over k factorial. Now, if we use mod, that's going to be equivalent to minus 3, minus 4, minus 5, dot, 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 all the way until, well, let's figure this one out. It's basically going to be 2014 minus k plus 1 minus 2017. That's how we're getting these numbers. And that's going to be minus 3 minus k plus 1, and that is minus 2 minus k. So minus 2 minus k. And this is all mod 2017. And don't forget that that's all over k squared, k factorial. Well, at this point, we can combine this. We can combine it. We're going to have negative 1 to the k, and it's going to be k plus 2, choose k. And that's all to the mod 217. But it's also equivalent to negative 1 to the k, k plus 2, choose 2, mod 217. Now at this point, we go and look at what they gave us in the question, that it's the sum from k equals 0 to 62 of 2014, choose k. Now that we can write in this form that we have created. It's basically going to be the equivalent of the summation from k equals 0 to 62 of negative 1 to the k, k plus 2, choose 2, mod 217. And when you do this out, just for the first few terms, I'll write them out. We get 1 minus 3 plus 6 minus 10 plus 15 minus 21, and so on, right? And this is actually equivalent to n over 2 plus 1 squared mod 2017, since our 62 is even. And this will only work for even numbers, that formula. So now we just put in our value for n, which is 62. It's going all the way up until 62. So it's 62 divided by 2 plus 1 all squared. And that is basically 31 plus 132 squared, which is 1024. And 1024 is the answer to number 23, which is C. Let A, B, C, D, E be a pentagon inscribed in a circle such that AB is equal to CD is equal to 3, BC is equal to DE is equal to 10, and AE is 14. The sum of the lengths of all diagonals of ABCD is equal to m over n, where m and n are relatively prime positive integers. What is m plus n? Before we dive right into this question, I have to explain something called Ptolemy's theorem. And Ptolemy's theorem is nicely explained in this diagram. And it states that if you have a circle and inside you've got this quadrilateral, then this holds true. So that is AC times BD in this particular diagram. It's the two diagonals, AC and BD. When you multiply them, it's equal to AB, which would be this side times that side, plus BC times AD, this side times that side. So that's what we're going to use in this question. So let's draw this diagram based entirely on the information given in the question stem. So now let's use Ptolemy's theorem to calculate our values. So we have three quadrilaterals, A, B, C, D, A, B, D, E, and B, C, D, E. On the first one, using Ptolemy's, I get x squared is equal to 10y plus 9. On the second one, I get yz is equal to 14x plus 30. And on the third one, I get x squared is equal to 100 plus 3z. And these are the ones that we're going to work with. So at this point, what am I trying to figure out? I'm trying to figure out the sum of all the diagonals. All the diagonals, I'll write them over here. The sum of all the diagonals is 3x plus y plus z. And that is eventually what I want to figure out. So first I have to figure out the value for x, the value for y, and the value for z. From this one here, I get x squared minus 9 over 10 is equal to y. From this one over here, I get x squared minus 100 over 3 is equal to z. And I can now substitute both of those into there. So I get x squared minus 9 over 10 times x squared minus 100 over 3 is equal to 14x plus 30. If you multiply through, you get x to the power of 4 minus 109x squared plus 900. And cross multiply and you get 420x plus 900. Put everything on one side and you get x to the power of 4 minus 109x squared minus 420x is equal to 0. Divide through by x and you get x to the power of 3 minus 109x minus 420 is equal to 0. Now at this point we have to factor, and when you do, you get the following: x, and 12, 5, and 7. 12, 5, and 7. And that's going to be negative, positive, positive. So obviously, since x represents a distance, it can only be 12. That's the only possible value. Substitute it back into here to get y. And I get y is equal to 27 over 2. Substitute x into here to get z, and I'll get z is equal to 44 over 3. And then go back and try to figure out our sum. 3x plus y plus z is going to be 3 times 12 plus 27 over 2 plus 44 over 3. And when you do that math, you get 385 over 6. And this is equivalent to our m over n. And they want you to find m plus n, which will be 391. So the answer to number 24 is D. What is the sum of all positive real solutions to this equation? We are going to make a substitution that will help us, and that is x is equal to pi y over 2. And when you make that substitution, you get 2 cos pi y times the cos of pi y minus the cos of, it's going to be 4028 pi over y when you make that substitution. And on this side, it's going to be the cos of 2 pi y and minus 1. All right. So at this point, we have to use some angle identities. And those angle identities, I'm sure you know. In particular, it's the cos of 2x. And that is cos squared x minus sine squared x. Now, if you put it all in terms of sine, it becomes cos 2x is equal to 1 minus 2 sine squared x. And then if you put the sine squared on one side, it becomes 2 sine squared x is equal to 1 minus the cos of 2x. And there's variations. We can divide through by 2. Sine squared x is equal to 1/2 1 minus cos 2x. And so on, right? You can also multiply through by -1, and that will give you 1/2 times cos 2x minus 1. So as you can see, there's multiple variations. So we want to get it into a form that we have. And if I multiply this by 2 sine squared x, then I will get cos 2x minus 1. And that is the form that this is in. So all I did was just took some well-known identities and just made it into a form that we can use. So we can now use it to substitute there. It becomes minus 2 sine squared pi y. All right, using that angle identity. On this side, we can start multiplying this out. It's going to be 2 cos squared pi y and minus 2 cos pi y cos 4028 pi over y, like that. And we can now divide through by 2 and then put the cos squared and the y squared on one side. So we're going to have cos squared pi y plus sine squared pi y, and then put the other guy over on this side, like this, cos pi y times cos of 4028 pi over y. Well, as I'm sure you know, this is equal to 1. So that works out very nicely. Now, at this point, we have to start thinking about how we're going to proceed with this equation. Well, one solution is that cos pi y is equal to 1, and the cos of 4028 pi over y is also equal to 1. If both of these are 1, then this would work. And I think this is sufficient. So if you guys remember that cos graph, it's basically going back and forth like that, right? And we want to know, when is it 1? Well, it's 1 here at 0. It's 1 here. This is 1, right? At 360, so 2 pi. And then it's, again, going to be 1 here, which is 4 pi, like that. So basically what that tells me is that if this is true, if the cos of 4028 pi over y is 1, that means that 4028 pi over y has got to be equal to some multiple of 2 pi, as you can see from the graph. So 2 pi times k. Simplifying this, divide through by pi on both sides and divide through by 2, you get 2014 over y is equal to k. So now that basically means that y is some divisor of 2014. What are the divisors of 2014? Well, 2014 is 2 times 19 times 53. So y can be any divisor of 2014. So that's going to be 1, 2, 19, 53, 38, 106, 19 times 53, or 2 times 19 times 53, right? But the problem is that we have to ensure that this also matches. But the problem is that for 1, 19, 53, and 19 times 53, if you were to sub it into this guy here, it actually gives you a value of -1 if you were to do cos of pi y for those values of y. So those ones we can't include because we have to ensure that it gives me 1 for both. So the only ones I can use are 2, 38, 106, and 2 times 19 times 53. All right, so my y values are 2, 38, 106, and 2 times 19 times 53. So remember, my original substitution was x is equal to pi y over 2. So that means x will be pi, 19 pi, 53 pi, and 19 times 53 pi. So the sum of the values of x are basically pi plus 19 pi plus 53 pi plus 19 times 53 pi. And when you add all those up, you get 1080 pi. And therefore, the answer to number 25 is D.